Hi guys, this is lesson 9.4 on linear, quadratic, and exponential models. So what we're going to be doing today is kind of bringing together everything we've talked about in the last few chapters and knowing how to tell whether it's a linear, quadratic, or exponential model. So a lot of what we're going to talk about it will be review. It's just kind of putting all these skills together. Okay, so the first thing we're going to do is we're going to look at these tables and graphs here, and we're going to see if you can tell which kind of shape they each make. So like if I were to connect my dots here on this graph, hopefully you can see that this makes a straight line, and so this would be a linear function since it makes that straight line. Remember, linear means line. And the way you can tell based on the table then is that they have a constant added or subtracted number in the x and y. So like here we're subtracting by 8.5 each time, it looks like. Okay, this next one then, if I were to connect these dots, looks something like that. So this would be a parabola, so that it would be a quadratic function then. And remember that the way we tell if it's quadratic based on the table is by the second differences. Okay, so you would find the difference between each of these y values, and then once you do that, you would go one more time, find the difference between each one there, and then that number in the second difference slot will be the same if they are quadratic. Okay, and then the last one we've learned about recently is exponential. And I like to say that exponential kind of looks like half of a parabola, kind of, and so that'll come down like this, and we are going to have values that are really close together at our kind of where it evens out a little bit at the bottom here, and then the values are going to get really far apart and increase really rapidly going up the other side. Okay, and the way we tell from the table then is that the y value is multiplied at a constant rate. So here we're multiplying by 1/2 each time. And so that's how we can tell it's a quadratic function then. All right, so here we're going to do the same thing, only we have to do the work of graphing each set of data. So I'm going to go ahead and graph these. So I've got 0, 24, way down here, 1, 96, 2, 384, 3, 15, 86, or 15, 36, and then 4, 61, 44. Okay, so go ahead and connect all those up, and you should hopefully see what kind of shape that is, and hopefully you recognize that as an exponential function. Okay, and the reason we can tell on the table then is that each y value is multiplied by the same number. As well, when we go to graph it, we can tell that we've got lots of values that are really close together down here, and then they increase really rapidly as they go up. Okay, the next one then, go ahead and graph that out. So we've got 110, 550, 20, 200, and then 50, 500. Right here, so. Okay, so this one, if I connect all of those, they should make pretty close to a straight line. So this one would be linear. Okay, and then the last one here, let's go ahead and graph that one out. So we've got -3, -14, and that one's going to go off my graph a little bit, it looks like, but we'll just do our best. -2, -9, -1, -6, 0, -5, 2, or what's 1, -6, 2, -9, and then 3, -14. So if we connect, oops, fix that one. So if we connect all those up, we should have a parabola there. And so since it makes a parabola, that would be a quadratic function. And the way we can tell also is that we have y values that start repeating. So like my -3 and -14 is repeated with a +3 and a -14. All right, so on these ones, again, we're going to be doing the same type of thing. We're going to be looking for a pattern in the data to determine which of our three models best describes the data. Alright, so what I'm going to do first then is I'm going to check and see if multiplication works on any of these. And I can already tell that it's probably not because I have a 100 that repeats here. So that tells me exponential would probably be ruled out, but now I want to check my differences for adding and subtracting. So here it looks like I would have added 64. Here it looks like I would have added 32. Here I added 0 between 100 and 100. And then from 100 to 68, I subtracted 32. Now, if it was linear, these set of first differences would be the same. So, since they're not, let's check for quadratic then. So we're going to look for the same differences in our second row of differences then. So here it looks like I subtracted 32. Here I subtracted 32. And to get from 0 to negative 32, I subtracted 32. So since these are all the same, my second differences are all the same. This one would be quadratic then. Okay, this next one here. So again, you can start either way. You can check with multiplying, you can check with adding. Okay, and just looking off of my numbers here, it kind of looks to me like adding's probably not going to work, so I might try multiplying first. So if I take 1169.86 divided by 1,000, I get an answer. Type this in here. I get an answer of 1.17. We'll round that too. So I took it times 1.17. Now let's see if that pattern continues on each of these. So I'm going to check each of these now by going 1169.86. If I take that times 1.17, I should get about 1368. So that works there. And remember I rounded, so it's not going to be precisely on. But we'll just check and make sure on this last one then too. So I'm going to take 1368.67, multiply it by 1.17. And I get about 1601. So it does look as though they are multiplying by about 1.17 each time. So since I'm multiplying on each one, this would be an exponential function. Okay, and then the last one here, I can either, again, choose to either try to see if I can find a pattern multiplying or adding. I'm going to start with adding this time. So it looks like here I subtracted 9. Here I subtracted 3. Here I added 3. And here I added 9. And again, this is kind of like that first one. I see some numbers repeating. So since our first row of differences was not the same, it's not linear, but now if I check and see if my second differences are the same, let's find out. Here I added 6, added 6, and added 6. So here my second row of differences are the same. So then this one would be a quadratic as well. So really these are just kind of checking, and you can look for a pattern either multiplying or adding first. It doesn't matter. And then if one doesn't work, try the next one. So then the last thing we're going to do today is just look at these formulas here, and these should all be review for learning linear formulas. It's been a while since we've had this one, but this is our good old slope-intercept form. Quadratic form fits this mold, and then exponential, the recent one we've been talking about, looks like that. So once we figure out what kind of equation is happening on each set of data, which one most closely fits our data, then we can put it into an equation and use that to predict future data. So what we're going to do is we're going to look at this table down here and try and figure out if we can figure out if it's closer to a linear model, a quadratic model, or an exponential model. So we're going to look at our y values again, see if we can find a pattern, and right away I can see that it looks like we're multiplying by 7 each time. So since we're multiplying by 7 each time, then that tells me that the exponential model is going to fit most closely. So that means we're going to take our form of an exponential equation, this a times b to the power of x, and then we're going to just sub in. So this a value is going to be what I started with, my initial value of 8. B is going to be what I'm multiplying by each time. So in that case, that's 7. And then x will be however many days goes by. And so that'll depend on this over here. But now I've taken that data and I've put an equation with it. So now I can use this, and let's say if I wanted to find out the number of people who would receive the email after 50 days, I can plug that in and I can get a pretty good estimate then. So this does kind of come in handy for if you're using it in some real life situations. So I think that is all for today. Yep, and so you can go ahead and get started on your worksheet then. Make sure you refer back to your notes if you need a reminder of what to do. And good luck.